December 5, 2017 20171205T090000 taken from the December 2017 issue of Physics World. Louisa Preston reviews The Planet Factory, Exoplanets and the Search for a Second Earth by Elizabeth Tasker. It is a difficult project to tackle, in a book, the subject of exoplanets, as it is one of the fastest moving branches of planetary science. Frequent news stories cite the discovery of new, habitable planets, and this popular topic of discussion has captured the attention of both the media and the public alike. It feels as though we are a breath away from finally discovering a second Earth somewhere out there in the cosmos. In The Planet Factory, Elizabeth Tasker, an astrophysicist at Japan's JAXA space agency, has bravely taken on the role of navigator for this incredible journey of planetary discovery, and the book does not disappoint. Early on, Tasker acknowledges and addresses an important fact hidden, that even at the time of writing the number of confirmed planets is changing, and that at no point should this book be taken as the complete knowledge, a whole story of the search. Indeed, since its publication many exciting exoplanetary candidates have been discovered and made the headlines, but science is a fluid pursuit and our knowledge is ever-changing, with each bit of new research building upon the last. This book will never be up-to-date, no popular science book ever is. However, the information contained within its pages is still invaluable and incredibly interesting. The Planet Factory is helpfully broken into 3 parts, so if you feel you are fully up-to-date with how our planetary system came to be, you could skip ahead to part 2 to get into the juicy exoplanet hunt. But I wouldn't encourage this, as you will miss out on some interesting stories and history woven into the science. To set the scene, we are taken back to the birth of the solar system and told the story of how the planets formed along with the sun, from a whirling disk of gas and dust. Gravity and heat from the young sun eliminated nearby gas to enable the inner small and rocky planets to form. Further out, gas and ice remained, resulting in the giant planets with thick atmospheres. Our solar system, 4 small, rocky inner planets and 4 immense, gassy outer planets, became the blueprint for planetary families and gave astronomers confidence in their explanations, that is, until the myriad of exoplanetary observations destroyed it. With tales from the Apollo missions, the moon landings, catch-coma exploits and anecdotes from the personal experiences of scientists, there feels in parts to be slightly more emphasis on the stories around the science than the facts that are being conveyed. This could perhaps be the only criticism of the book. For someone who knows the field well, this is an incredibly interesting part of the history being told. However, for someone new to the topic, it may slightly obscure the main take-home information. This is very much down to reader preference, however, and does not in any way detract from a brilliantly written first section. Part 2 is where we get into some fascinating exoplanets. Tasker introduces the reader to the super-Earths, such as 55 Cancri, and hot Jupiters, such as WASP 17b, and uses these stellar systems to continue the discussion of how the worlds in our solar system came to be arranged. We also learn about the measurements we can glean from distant exoplanets, such as size and density, and what this can imply about their compositions. This is often the case with measurements such as these. What we think we know and understand from the data can be interpreted in multiple ways. For example, the radii versus mass observations of exoplanets such as 55 Cancri implied it was too small to be a purely gas world but too large to be a rocky one. This exoplanet could therefore be a hybrid world of rock and atmosphere, a carbon-rich world with a diamond mantle, a silicone-rich world covered in seas of supercritical fluids, or even a world swimming in magma. The more we learn about exoplanets, the more questions we have, and this section does well to try and answer some of them. Plus, it charmingly reminds us that the scientists involved also don't know the answers just yet, but that is part of their enjoyment of the exploration process. Finally, in the last section we learn about Goldilocks worlds, and as Tasker eloquently describes, our insatiable thirst to find habitable planets. After earlier discoveries of Jupiter-sized worlds squished close to the stars, planets comparable in size to the Earth are starting to be found, giving us genuine hope that a world like ours isn't alone. Tasker then delves deep into what makes the Earth habitable and the relationships between stars, planets and moons that can influence the potential for a planetary body to host life. She explains in detail many of the exoplanets currently found and the potential habitability. In particular, we learn about the red dwarf star Gliese 581, which was once thought to have a family of 6 planets orbiting it, with 2 of those, Gliese 581 grams and B, inside its temperature Goldilocks zone. The existences of Gliese 581 F and G were called into question a few weeks after the discovery, with the non-existence of Gliese 581 F accepted. However, after unusual magnetic activity was observed on the star's surface in 2014, it was realized that this created a wobble that mimicked that of the influence of a planet. When these data were considered, we suddenly lost Gliese 581 grams, and to top it off, Gliese 581d was erased too. Through this case study and nicely explained process of scientific exploration, Tasker wonderfully highlights how difficult the hunt for planets is without coming across as pessimistic. Overall, I would highly recommend this book. Tasker has a lovely way of writing that makes the story easy to follow while addressing some rather technical details. Aimed primarily at an undergraduate level and for anyone wanting to learn more about exoplanet research, this book is a thorough guide into what way these hard-to-find worlds are opening our eyes to the cosmic possibilities for life, and especially how our own planet and solar system family came to be.